Hi there, this is Dr. Embody. Take a look at Project 7. In this case, we're practicing functions and lists. Put the two together. And the problem actually revolves around the notion of the one percenters. You hear that in the news. The top end of the income bracket, it's the political year. And so, who are the 1%? How many are there? How many are in the 0.5%? How many are in the 70%? If I make $100,000, what percent does that put me in? And so this project is takes a set of data and then can answer those questions. And at the same time, we add a little bit of plotting on there just to show you how easy it is to do. Got to be a little careful. Note in the project where it says to only plot the first 40 of the data items. It turns out that the income distribution is so skewed that if you try to plot all of them, you basically end up with the cumulative plot, which should be this nice curve, actually ends up being a vertical line and over. So it doesn't even look like you plotted anything. So be careful with that. I came across that when I was developing the project, and I thought I had done something wrong, but it was plotting perfectly fine. That just shows how skewed things are. But it's interesting. It's actually kind of interesting to play around with this, and hopefully you'll enjoy that part of it too. So let's take a look at how this works. So there is a project description, and there are a number of pieces to it. So for example, we show that this is what any particular line looks like. Watch out a little bit. That neat little hyphen there is in the data file is actually some kind of a weird hyphen character, and so that could trip you up a little bit. Just basically ignore it because you can split this thing and there's a space on either side of it, so you can pretty much ignore whatever is in there. A couple of other things is notice like this piece of data, it's an int, but it also has commas in it. And so when you take a look at this particular value and you want to make it into an int, you're going to have to manually remove the commas and see what you end up with. Same thing down here. Here's one that's a float. That's the same way that you can tell it's a float. There's a decimal point right there, and it has commas. So remove the commas and then do the converting. I found it. I wrote a function to handle ints and a separate one to handle floats. You might find it that you can that makes more sense for yourself to do this as one single function, but that's just a couple of things to think about. I tell you what the columns are. Okay, so column 0 is the bottom of the income range. So we have a range here from $5,000 to basically $10,000. There's 13 million people in that range. This then is the cumulative, so that says, so this is saying there's 13 million in this range. There's 36 million who have this much or less for their income, right? So it's cumulative. This is cumulatively how many people are below that point, and this is the percent that we're at. So we're really interested a lot in the questions that they're asking. Okay, so this income range is represents again, this is a cumulative percent. So 23% of the individuals earn this amount in this range. If we take all those 23% or 36 million people, add up their salaries, there's the cumulative salaries involved, and then here's the average salary in this range. And so we have a bunch of columns of the data that looks that way, and it's not a very pretty looking set of data. We could take a look at the data itself, and in fact, so that particular one, there's the row that I had copied into the project, and what we're doing is we're asking questions such as this, is that if I have an income, say, of $42,000, which is in that range, then that means roughly 67% of the people are earning less than that. Okay, now it's not exactly 67 as some, I mean, this is for that whole category, so we're off. It's plus or minus some number, but we know it's not 100%, we know it's not 20%, and so on. All we're asking is grab this number, and then we'll also ask the opposite question: is that if I say, all right, I give you the 67%. Who earns less than that? So in this case, it would be, I don't know exactly the exact amounts, but 67.6% was in this range. Therefore, 67% must be $40,000 or less. Right? So it's a little rough, but we still get to look at this chart and gain some information out of that. And notice these ranges are going up by by amounts of $5,000, and then it changes up here, starts going up by even greater amounts. And you do get another little thing that can get you, is that notice everything here has separated by commas, and then the last one is and over. Whoa, really? Okay, so that means what's in column 0, 1, 2 in this case is the word over. So you're going to have to account for that. In any case, so be careful of that in terms of the data. In gory details, I specify a lot of functions. Yes, you do have to have these functions, and yes, they have to do it. Just like I say, I give some hints in there. And I also give you some testing. So if you use the 2014 data and a value of 90 for this particular function, this is the information that will be returned. So you can test your function out. Similar with get percent. I've done that to hopefully give you a chance to better test your data. When you find the average, watch out. It is, to find the average of the whole data file, it's not the average of the last column of the data. Okay, it's not mathematically valid to find the average, but the average of averages just doesn't work mathematically. All right. So if we take a look at how this thing works, there is stuff at the end there, but let's actually take a look. So enter a year, and we have to have some. If I give you some bogus stuff, it says no, that's not a year, or if I give you something that's out of the range, no, that's not right. So the last year we have. I gave you two sample ones, the year 2014. Notice the little delay there to actually do everything. And so for that year, you are to calculate the average and the median. Okay, and we require you to have functions to do that, so you can check against those values. And then find the cumulative percentage. Notice that I say that you do the first 40, because it turns out that if you try to do all of them, the plot just goes right up the vertical line and right over here, and it's not a very interesting plot. In fact, you can't even see it. So I tell you to do the first 40 values, and so now you can see what when we look at incomes versus the cumulative percent, by the time you get out to 200,000 here, you are almost at 100% of the people, and of course that's there are plenty of people who earn more than that, but there aren't very many of them. Okay, so how does the rest of this work? Well, if I take the range, if I say I want a range, so we enter a percent. So what's, who's in the 70%? So 70% of incomes are below 45,000. If I did the P, it says enter an income. Let's do 120,000. Notice no commas in there, and it says, oh, that's the top 94%. So we're, there we go. So 94%, or basically 95% of the people earn less than that. So that means the top 5% is earning less than that. If I put in some value, or if I put in no value, that's what I get. My data things, I call it the data list, so I can say, what is that first one really doing? Get a range of my data list and a percent. So when I gave it to 70%, then it came back with that value. So this number that comes back here is pretty much a row of the columns. We're starting from 45,000 going up to basically 50,000, and it's 71%. So that means that since I asked about 70%, that's the 70% here, then we know that 70% will be below 45,000. So that's why I printed that particular value. Similarly, when I said get range, looked at percentage, and this is how you can test your data, and I gave it 120,000. That's because I have a typo there. It's not get percentage, it's get percent. Let's try that. There we go. And again, so we see here that when I gave it 120,000, it gave me that range of values. So yeah, that's really that's really it. Again, what we're doing is we are trying. The whole point of this project, from a programming standpoint, is find the appropriate row in this table. So I have a table, and what we're really saying is, oh, I'm looking for percent. Oh, that's the percent row. I'm looking at this column, and if I say, if I provide some percentage, I'm really interested in a particular row. So find the row that's associated with that percentage. It'll never be exactly, and so I define what that means in the description. And the other part of it is provide an income range, and again find the appropriate row. So that's what we're trying to do. We're just looking through this data to find the row, and what you do is you read this data in once. You read it once, and you make a big list, and then you just keep looking through that list. How you organize that list, that's up to you. But we do specify what gets returned by your functions, and as I showed you, you can test your functions individually to make sure that they're right. And I gave you 2 different data files. All right, with that, good luck.